Welcome to Analytically Delicious, Insights into Food Safety by LVA. Join us as we explore the latest developments, trends, and challenges in ensuring the safety of our food supply through analytical techniques, uncovering the science behind what makes our food safe and delicious.
Welcome to Analytically Delicious, the podcast where we delve into the fascinating world of food science and the analytical methods that ensure our food is safe and nutritious. I'm your host, David Steiner, and today we have a very special episode lined up for you. Joining us is Dr. Veronica Lattanzio, a senior researcher from the Institute of Food Production at the National Research Council of Italy. Veronica is an expert in the field of food safety with a particular focus on mycotoxins, which are toxic compounds produced by certain types of fungi that can contaminate crops and pose serious health risks. In this episode, we will explore the origins and impacts of mycotoxins, how they infiltrate our food supply, and the cutting-edge techniques used to detect and mitigate their presence. Veronica will share her insights on the latest research and advancements in this critical area of food safety, providing us with a deeper understanding of the challenges and solutions in managing mycotoxin contamination. To get ready to dive into the world of mycotoxins and learn about the meticulous work being done to keep our food analytically delicious. So thank you very much, Veronica, for joining us today, and welcome to our show. In our previous episode, we had an in-depth discussion about pesticide analysis and various strategies used to manage pesticide residues in our food supply. Today, I would like to shift our focus to mycotoxins, and in this relation, I would like to highlight one of your current projects you're working on, namely the Food Safety for EU project. Could you maybe share some insights from this project?
Yes, sure. Good morning, David. So very happy to be here and to start talking about Food Safety for You. Food Safety for You is a project on food safety in Europe. It's not entirely dedicated to mycotoxins, but we could discuss mycotoxin-related issues over the 3-year journey because we rediscovered that is actually one of recurring food safety issues. There is a lot of attention also by Food Safety Authority. Basically, what we were asked by the Commission when we were founded with this call was to design and deliver a multi-stakeholder platform for food safety in Europe. And this was a so-called policy-driven call. That means that this group was expected to be driven to co-design input for the future policy in Europe. And to cut the story short, in the end, we could provide some input for the updated version of the Food 2030 agenda. In the project, what we have done is to discuss with this multi-stakeholder group about the most hot food safety issues. And I have to tell you that when we mapped the European food safety system across Europe, so we ran in-depth interview with representatives from food safety authorities across Europe, mycotoxins was one of the considered a re-emerging issue across Europe, especially related to the circularity of resources and to the climate change. What food safety authorities highlighted is that it is a very well-known risk, but they still need methodology and regulation and guideline to cope with this new big trend, such as the circularity and the climate change. So I would say that a big part of Food Safety for You is dedicated also to mycotoxins.
It sounds like a lot of effort has already gone into making this platform effective and also inclusive. Can you also already share some key results?
Yeah, it was the project, let me clarify, was a coordination and support action. So that means not experimental research, but a lot of capitalizing the existing knowledge, generating new knowledge and make this available. But also within the project, we activated the 4 social labs, which are briefly a cycle of workshop that also have some space for experimentation, so that run also some pilot action. The 4 social labs were dedicated to the risk analysis. So in this social lab, we could pilot something regarding mycotoxins and food contact materials. So we generated some input for the new regulation. And in case of mycotoxins also, we generated a toolkit for young risk assessors. It's really a kit for creating awareness about risk assessment. So you can play with the standard data format by EFSA, where you can input your occurrence data and then calculate the risk of exposure. It's really to create awareness. Then we had another social lab on where we discussed the alignment of funding programs and research priorities. This is something that also is very hot within the Commission. We all know and we realize that food safety is not a per se founded topic. It is more and more embedded in other big topics such as circularity, sustainability, and so on. So we mapped the situation, and except Germany or France, dedicated also to food safety are not really in place. And then we had another very important social lab that delivered our proposal for strategic research and innovation agenda, which was then presented in Brussels at the Food 2030 conference. And also this agenda, which is complementary to the existing one. In this agenda, the multi-stakeholder group was looking at the sustainability transition from the food safety angle. So you can find there several input on potentially or re-emerging food safety issues related to the transition to the sustainability, and some proposal on how to cope with them. And the last one was all about communication. The project was founded in the same period that in which the new transparency regulation, which is the amendment of the general food law, came into force. And within the EFSA, there was a lot of concern and effort about improving their communication to the public. So this is also one of the support that they asked to the platform, which has been working in synergy with EFSA to experiment some new communication model to the general public. So you can find also there's the result of this experimentation, some TikTok videos or and also methodologies for communicating to the public.
I understand.
So this is more or less what we experimented, yeah.
Okay, that sounds very impressive, and I think it's very clear that this project is making a very significant impact.
Just if I may, the platform is still in place because the project ended up in December 2023. But as asked by the call, now we are the European Food Safety Platform, which is an independent platform. So the network of experts is still in place, and we have a roadmap for the future.
Okay, I see. Veronica, as I mentioned in the beginning, within our last episode, we were talking about pesticides. Can you maybe explain the primary differences in managing mycotoxins versus managing pesticides in agricultural practices?
Yes, my personal opinion, the main difference is that mycotoxins are natural contaminants, while pesticides are added by humans. So I think this is the most relevant difference. That means that provided that you are really committed that you can manage pesticides, you can replace them, you can find, let's say, more eco-friendly alternative, while mycotoxins, even with your strongest commitment, you cannot completely avoid them because there are some factors that we cannot really control 100%. So this, I think, is the main challenge in management of mycotoxins. And okay, we have a lot of best practices, agricultural practices. We have, now we have, for instance, the precision agriculture, we have satellite data. So also thanks to the technology advances, we can really generate target suggestion of intervention measure. We have the models for the farmers, but really there is something that is out of our hand. So I think this is the biggest difference. And there is another difference, if I may, is that you put pesticide in the field or in really I guess not post-harvest, but the early stage of post-harvest, while Mycotoxins can be produced, as you know, in the field, but also during storage, transport, and processing. They are chemically and thermally stable. So it's a kind of concern. You when thinking about the management, you have to think about the whole food chain more than pesticide, I guess.
And what are the key factors that influence the presence of mycotoxins?
Basically, it's climate, of course, agricultural practices. To tell it in very, very simple word, if you have some residue of fungi from the previous crop, you can increase the mycotoxin production infection. Then you can go for resistant varieties. There are some who are fully natural. So really you have to select the right varieties. There are a lot of agricultural practices, but also temperature, humidity, so climate parameters. So as far as I understand, all the predictive models are really based on mycotoxin occurrence, but also on climate parameters such as temperature, humidity, the rainfalls, and so on.
So we can say that managing mycotoxins is quite more complex because their presence is less predictable, as you said, and also they can occur after harvest during the storage, right? When we compare it to pesticides.
Yeah.
And can you describe maybe some of the common countermeasures taken in response to the mycotoxin contamination?
Besides, as I told you, good agricultural practices and also the research, I would say that is doing a lot. For instance, you can use biocontrol agents, which are, for instance, competitive microorganisms, such as non-mycotoxin producing fungi that can compete, for instance, on grapes with the toxigenic ones. So in this case, you can really reduce the mycotoxin production. So you can use biocontrol agents. I would say also, no, I'm a chemist, so I would say that an ethical use of pesticides, fungicides, can indeed reduce a lot the risk of contamination. This is in the field. While in storage, we have a lot of possible measures. You can control the atmosphere, the temperature, the humidity. You have to use clean silos. Also, for instance, there you can use some natural preservant like essential oils, for instance, that can reduce the fungal contamination or keep it under control. Is under debate because from the farmer's point of view, the real prevention and management happen in the field. Once they harvest, according to them, is not really the most efficient, let's say, measure to control, to detect and control mycotoxins. Also, you can have decontamination, detoxification, really in place, even though the research has been done a lot. Every kind of measure has to be authorized by the EFSA, by the EC. So that means that even though there is a lot of research, I would say that the number of measures that you can really implement in the field, also in terms of biocontrol agents, is not so high.
So you mentioned biocontrol agents, and you have described it in a way that there is some kind of competitive situation between a fungi which is not producing a mycotoxin with a fungi which is producing mycotoxins. So maybe for the listeners out there, why is a fungi in general producing mycotoxins?
That's it's not really my expertise, but is in the DNA, is in the DNA, and also it's not always easy to understand the amount or the exact time, because mycotoxins are secondary metabolites. That means that are not specifically linked to a specific response to the fungi, to the environment, and so on. So indeed, there are some factors that can, let's say, favor the infection, but there is not always clear relation between the mycotoxin production and in the fungi infection. So a lot of research has been done also in this case. For some very known fungi, you can predict, but for other, not really. And also, as a strain, there are some toxigenic ones and some non-toxigenic ones. So basically, it's in their DNA.
So Veronica, you mentioned already the topic of climate change. And for me, it would be interesting how climate change will influence the mycotoxin patterns in the future.
Yeah. I think we cannot. For what I have seen, what I've learned, and the research that I see, what I would say is that for sure, climate change will change the distribution pattern of the mycotoxins. That means that all the models we built until now will no more work in the near future. What we have seen, for instance, the first toxins that everybody has in mind is the aflatoxin. So we have seen appearance of aflatoxins in regions where they were not really a problem. You mentioned when we were chatting before the issue of aflatoxin 1 in Serbia. For instance, in the north of Italy, where we produce Parmigiano Reggiano, a lot of very famous cheese, there is a lot of attention to the changes in aflatoxins level in maize due to the climate change, when it's particularly, for instance, wet, the climate. And also, Italy is one of the European regions I would say more sensitive to this issue, because if you see the climate, the temperature data is becoming hotter and hotter. So we are close to the African climate rather than other. So we are really becoming tropical or subtropical. And so we expect an increase, for instance, of aflatoxin contamination. But basically from research and modeling, and also from the risk assessment point of view, I would say that the main issue is that the occurrence will not be really predictable. So that means that we have to do a lot of effort in collecting new data and generating really new models to predict what will happen in the near future. And in this respect, also having what we expect is really to the spread of artificial intelligence in this. There is a lot of work that has been doing in this period to capitalize the unstructured data and also the new ones to generate new models.
I understand. So maybe also important for the listeners to better understand this kind of shift of aflatoxins you mentioned. So there is a specific fungi called Aspergillus flavus, which is producing aflatoxins, and this is basically done under very high temperature conditions. And since climate change will also increase the global temperature, this is a realistic scenario that these very toxic compounds may be also more present in regions in Europe where we did not have to tackle them before. I think this is important to understand. Also, the bigger problem of this topic.
Also, the severe rains that we are facing with can contribute, no, because of the humidity.
Veronica, have there also been any new mycotoxins identified that are directly linked to changing climate conditions?
Not really, as far as I know. Normally, there will be always new mycotoxins because of the powerful of the technique that we are applying to investigate the problems. No, as far as I know, no. While we have several mycotoxins who are produced, for instance, by the plants as chemically modified forms to try to detoxify the parent, no, let's say the parental forms. Not really, but this is for what I know.
You already mentioned the powerful analytics behind that, and our show and our podcast is called Analytically Delicious. So, of course, you also want to talk a little bit about analytics. So what role does actually high-resolution instruments, for example, play in monitoring these climate-driven changes in mycotoxin patterns?
Yeah, I think that the high-resolution MS is really a technique with a huge potential in terms of metabolite discovering, exploring new trends. Just for non-analytics, while in the official control, no, we are used to detect specific contaminants, which normally are those that deserve the attention of regulators. those for which we have regulatory limits, so we have to comply with the regulation. With high-resolution MS is a technique that is able to screen hundreds of compounds in a unique analysis. So I think, in my opinion, the most important point is that with high-resolution MS, you can do both at the same time. You can perform target analysis. So once you have a sample, you can verify compliance of this sample with regulatory limits, and then you have a lot of data that you can screen for, and you can investigate about the presence of metabolite, unknown compound. You can match this data with databases. So I think the powerful of the technique is the retrospective analysis, really, because you while you perform compliance and monitoring, you can acquire data and you can screen for metabolite posteriori or at the same time. So it's really huge potential. Also because it's powerful to really give you confident information, trustful information in the structure identity.
Can you maybe explain this term retrospective analysis a little bit to our listeners out there?
Means that you can do this. Okay, you acquire your analysis, you quantify your target analyte, and then 1 month you store all the other data, and 1 month after you read in the newspaper that has been a month very hot. So you can think about looking for other metabolite that you didn't think before. So you come back to your analysis, you can extract numbers relevant to the other compound. And once you have this number, which rely on the molecular weight, basically of your compound or some part of the molecule, you can match this number with a database, your own or another one. So you can have, so normally you match different parameters. This is really for analytical people. You match the retention time on the column, you match the molecular weight. But if you are a smart analytical chemist, you can also think about the kind of chromatography, the extraction mode, and really you can go deep into the molecular identification. And I think what we still miss a little bit in this is to standardize a little bit the approaches, because sometimes it happens that you find a metabolite that your colleague in another part of the world is not able to find. But really, we are on the way.
Yeah, very important. Standardization, I fully agree. And Veronica, last time in our episode, we also talked about the analytical advancements in the area of pesticide analysis. And we figured that due to the technical improvements in the last decades, that the triple quadruple MS especially made some significant changes in this area. And I think this is also true for mycotoxin testing. So we can really say that the LC-MS systems are the typical working horses in routine laboratories. So compared to the high resolution instrument we were talking now, how do they differ, these two different systems, how do they differ in terms of efficiency and also sensitivity?
Yes, for what I have seen in a research lab, they can be highly performing. When you have a researcher that doesn't have time constraint, is very knowledgeable in the field. But when it comes, for instance, to routine lab or official control lab, I still think that the high-end, the triple quadruple will stay in place for official monitoring, because normally they are more robust and sensitive. Robust, I mean in routine. So they normally require less maintenance. There are some patents who are very, very robust when you have to inject hundreds of samples, non-purified samples, over 1 week. While high resolution, just imagine that you have to calibrate every day and high resolution spectrometer. So I think it's still not really straightforward in routine. I know that in the veterinary drugs or in the pharmaceutical companies or in the pesticide, the retrospective analysis and looking for metabolite is becoming routine more than in the mycotoxin field. So I think really they are complementary. But for official control, in case of mycotoxins, you imagine we have just 12 or 15 mycotoxins if you consider the regulated and the recommended ones. So a good triple quadruple is more than enough.
Mm-hmm. And aside this triple quadruple MS, we know that there are a lot of rapid test systems also in place, like ELISA test kits or also strip tests. How do you compare this, and what would you also recommend, or when would you recommend using the rapid test systems, and when would you go for the reference analytics?
Yeah. That I always used to say, go for the fitness for purpose approach. I think this is the universal answer. I mean, you have to think about the quality and the use of the data you have to generate, even an official control lab. I have to say that for mycotoxins, the regulated ones, we have a lot of very good ELISA tests and strip tests, which are routine even in official control lab. Indeed, they are accredited. They can be accredited. So you imagine an official control lab that analyzes 100 of mixed samples per day. The ELISA is very well performing. Indeed, the positive samples, the suspect non-compliant samples, has to be reanalyzed with the official. So I'm not saying that the ELISA or the strip test can replace, in terms of regulatory compliance, the official method. But what I have seen is that they are quite robust. We have a regulation for validation, so for checking their performances. So indeed, they are really straightforward and reliable in auto control, process management, also for high throughput screening of the sample. So I would really recommend to investigate in this.
Okay, so it's important to use it some kind of to get the first information out of your matrix, and if you want to get a deeper knowledge of the contamination, then you go for the reference analytics.
But okay, I think if I may, if we look at the future or third countries where we don't have completely data for risk assessment, for instance, or to build a model for climate change, I would say that, for instance, for aflatoxins, we have strip tests and ELISA tests, which are have the same sensitivity of HPLC. So instead of having nothing, what I would strongly support is to implement rapid tests for monitoring, also even human biomonitoring. Now we are used to use ELISA for animals to check zearalenone and metabolites, for instance. So I think it's something that is not so impossible. And instead of having no data, I would strongly support implementation of the rapid test in countries where they don't have enough analytical capability. That's my opinion.
And how does it look with the standardization of these test systems? Because you mentioned already before, standardization is a very important topic. How comparable are the results coming from the rapid test systems and the LC-MS?
Yeah, I would say yes. Okay. I think in the mycotoxin field, we are quite far also for the standardization. As I told you, you can accreditate, for instance, the ELISA test, also the strip test. For mycotoxins, we have a regulation to evaluate with acceptability criteria of screening tests for mycotoxins. So we have also official guideline. And also for mycotoxins, we have proficiency tests, we have reference materials. So I think we have all the tools already in place to demonstrate the reliability and the quality of the data that we generate with rapid tests.
Veronica, as we conclude our discussion today, could you share your insights on what regulatory changes you anticipate in response to mycotoxin management, and how will they impact the agricultural industry and food safety in the future?
It's quite a difficult question because, as you know, perhaps for non-experts, we have in Europe, we have a community that generates scientific evidence. So we know the risk. It's called risk assessment technically. But what happens is that this community, which is led by the EFSA, the European Agency, the European Food Safety Authority, are then communicated to the European Commission. And then we are in the field of the risk management, which is a political decision. Risk management is based on data, but then they have to balance also stakeholders' interest and policy and so on. Say that you can imagine that producing data and giving evidence of a risk, even with an accurate method, takes some time, but delivering regulation takes a lot of more time, and is not, you cannot give for granted that in the end you will have regulation. Just let me mention, we have some opinion by EFSA on some modified mycotoxins. We have some also opinion by the WHO on this. Now, the scientific community is, let's say there is a kind of agreement in terms of concern about some form of modified mycotoxins and their in vivo toxicity, while we don't have still even recommendation for this. A recommendation means that you don't have to comply with, but you are strongly encouraged to produce data, no, and to pay attention to those molecules. And we still don't have regulation for masked modified mycotoxins. A very recent example we had in April 2024, this year, an update of the regulation of maximum permitted level for the oxynivalenol, and they still consider the oxynivalenol only. When I start working with antibodies in the university in 2008, and the evaluators of my project asked me to evaluate the cross-reactivity of the antibody towards 3,15-acetyl-deoxynivalenol and the oxynivalenol glucoside, because there was an opinion by the JECFA, and we were expecting maximum permitted level considering the sum of these forms. So we still don't have them. Perhaps it's more likely that you have a modified form in what is called tolerable daily intake. So you have to pay attention to the exposure, but we still don't have regulation because, as I told you, we are in the area of risk management that has to take also into account interest of the stakeholders, for instance, the market, and every regulation is a modification of the market flows, so, and can create. And also now there is a lot of debate between safety and security, also in Europe, because of the geopolitical situation. So I think this will delay the delivering of new regulation, because also in Europe we have people that cannot afford food. So we have to really balance the safety and security.
Perfect, I understand. Veronica, it was great to talk to you, and thank you for taking your time.
It was a pleasure for me, and thank you for inviting me.
If you found today's conversation as enlightening as we did and want to stay informed about future episodes, remember to subscribe to our podcast on Spotify or YouTube. By subscribing, you'll never miss a bite of our delicious insights into food safety and analysis. And for those of you with burning questions or lingering curiosities related to our today's episode or any other food safety topic, don't hesitate to contact service at lva.at. Your questions will be addressed either directly in our next episode or by our team of experts on our website, www.lva.at. Thank you for tuning in, and until next time, stay safe and stay informed.